You're rude. So, let's get these done, guys. All of these are special case factoring. I taught you the Xbox method for trinomials only because of the fact that it was not taught at any other point. It's kind of expected for you to already know it. Algebra 2 here, they expect you to memorize all of the special case factoring types we have. So we'll start with Alicia. What can I factor out of both terms in number 1 before I start? 3. And what will I have when I factor 3 out? Minus 16. Oh, if you said it, I just was waiting. I couldn't hear. That's all. Okay. N squared minus 16. So we look at n squared minus 16, Alicia, and we know that will factor. I don't know if you know the name of it. That is called what? You don't know the name? That's okay. That is difference of two squares. Okay. Oh, never mind. You had it. I apologize. So, difference of two squares. I'm picking up pieces of powdered donut edge. Okay. So, n squared minus 16, folks, this is the equivalent of saying n squared minus 4 squared. So our a is, if we look at factoring the difference of two squares, our a would be n and our b would be 4. Now, of course, Alicia comes from a place where they've already taught this. This factors into what? And we're done. Now, this workbook in particular loved using difference of two squares. And I think that's what we're going to end up using like almost exclusively on quite a few of them. So we're going to keep jumping around. Destiny, number 2. What can I factor out of both terms first? And? There's something else you can factor out of both terms? No. No. Number 2. I can factor also. Holly's been saying it a couple times. X. I can factor 3x out of both. If I factor 3x out of 3x cubed, what do I have left, Destiny? No, I factored 1x out of 3x cubed. So what would be left? How many x's? Yep. So it's x squared. And 75x, if I factor 3x out, what do I have left? 25. So this is once again. Why is it? Because I took an x out of both items. So if I take an x out of x cubed, it drops down to an x squared. Okay. So this is going to be x squared minus 5 squared. So my a is x and my b is 5. So what will this factor into, Destiny? It's difference of two squares, because that's a square and that's a square.
So it will be a plus b and then a minus b.
Which is, what's my a?
X squared.
A is just x.
Plus 25.
No, what's my b?
Oh, 5 squared.
So b is 5. So x.
Plus 5 and then x minus 5.
There we go. Might be easier if we take the earbud out of the right ear. Nope, it's an earbud. It's not. It's on wires. So. All right. Alfaro. We're coming to our first quote-unquote difficult one. Because of the fact that this is an m to the 4th, but that's going to be okay. So Alfaro, we only have 2 things. What do you think this is? 9m to the 4th minus 16. It is the difference of two squares. So what is 9m to the 4th? If I were, what would be the square root of that?
Would it be 3m to the 2nd?
3m squared, absolutely. So this would be 3m squared minus, and what's 16? Is what squared? 4 squared. So my A is what, Raymond? So when I gave you the formulas at the top of your notes, it's a squared minus b squared equals a plus b times a minus b. So what is my a in this? 3m squared, and what's my b? Just 4. Just the 4 part. Right? No. Once I factored this x out, then it turned in inside the parentheses is a difference of 2 squares. Because the 16 doesn't have an m to give up. Good questions. You're fine. So Raymond, what's this going to factor into? So it's going to be a plus b, which is going to be good job. Dmitrievsky, you're up.
Can't be serious.
No.
Okay, for number 4?
Yes.
We got 4
4 r
squared,
squared.
and then put squared out there, yeah. Then minus
Mm-hmm.
3.
Mm-hmm. All right. So what's that going to be when I factor it?
4r squared
Yep.
plus 3,
Yep.
and then 4r squared minus 3.
Yep.
Yeah. Was this using this difference of 2 squares?
Yep. He did.
All using
Quite a few of the. We're starting off. Most of these in here in the beginning are be difference of 2 squares, just the way they are. Yes, sir.
So on the test, are you going to make us use all of these?
Yes.
All of these?
Yes.
Give us the formulas to read.
No. You have to memorize them.
You want me to memorize them?
Yes.
You know the one.
Every single one of your Italian foreign exchange students has them memorized.
Well, I don't really
I guess I'm
think
going to sit next to one.
that complicated, right?
No, it's not.
She's lying.
Yes, it is. The sum of 2 cubes and difference of 2 cubes is kind of.
Were you here yesterday?
I was.
Oh, okay.
I paid attention.
I'm just checking.
It was just that those ones are like.
I was actually struggling with this.
They are. Yes. Yes. What do you mean? Oh, because Elias said period, so I put a period. Yeah. Okay. All right, Kaya. Did you say yeet? Okay. Kaya, what can I factor out of this first? 3. Yes. All right, Kaya. This is what? Because I can factor 3 out of both terms. Remember, the first step is always, is there something I can factor out of everything? Do it. You have to look. That's all there is to it. It is not, because 4 is not a cube. It is the difference of 2 squares. So here it gets a little weird, you could say, if you'd like. I don't know. End of the 6th is something squared. What is it squared? Yeah. Okay. So this is going to be n cubed squared. And then 4 is what squared? 2. And now we can factor it, Kaya. What is that going to turn into? Difference of 2 squares in here. What are we going to get? What's my A inside of here? No. No. In here is an A value. What is my A value?
Oh, it.
Close. N cubed is my A. That's the thing. An exponent could be attached to it. N cubed is my A value. What's my B? 2. No, just 2. A is n cubed. B is 2. So now I factor using difference of two squares, which is A plus B. So what will I write? Just 2. Because B is 2. It's A plus B times A minus B. Yeah. There we go. Kaylee, now that we've put our phone away, if you'd like, I can call you Kaylee Elias. Oh, no, I said Kaylee. That'd be really weird if your name was Kaylee Haley. But I like it though. If you'd like, we'll talk to Leslie. We'll see if should your name be Kaylee Haley. And if he says yes, then whoa. Culturally speaking, your name, just like a very common Irish name, is Shannon. Your assumption that a name has a gender specificness to it is erroneous. Yes, it's a very common Irish name.
Yeah, we'll see.
Yeah. Okay. All right. Moeller.
No. Oh, well, there's 2 of us, so you're picking out Seth now, right?
Okay, Kaylee. He's not here. No. So, he looked at Riley and he said, "I don't like you anymore," then got up and walked out. It'd be like that sometimes. Low key. So, all right, Kaylee. So this is what? Yes. Feel it.
Difference of 2 squares or 2 cubes.
It is only difference of two squares because 9 is not a cube.
Okay.
Because 9 is not a cube. So this is difference of two squares. So x to the 6th is what squared? X cubed squared. 9 is what squared? 3. So what's my A? What's my B? There we go. So this is going to turn into A plus B, so I'll put what? X cubed plus 3. You don't know my question, which there was no question because you weren't paying attention. You were talking with Pishamun. Okay? And then x cubed minus 3. All right, now we're getting to 7 to 12. Mia Porreco is coming up next. And she'll have the first one that is not a difference of two squares. I don't know what you just said. We ready to go? All right, first thing, Mia, what can I factor out of every single one of those? This one's got something I can pull out of every single one first. Ah, 12 is factorable by 2, but 3 is not. 3 and I can factor 3 out of 3, 12, and 12, absolutely. What else can I factor out of all three of these? A B, because all of them can give up a B. So yes, so if I factor out a 3B, what do I have left? If I factor 3B out of 3B to the 7th, what do I have left? B6. Okay. If I factor 3b out of 12b to the fourth, what do I have left? No, I'm not subtracting. So I'm dividing. So 12 divided by 3 is 4. So, and I'm taking away a b, so it'll be 4b to the third. And if I take 3b out of 12b, I get, once again, 12 divided by 3, I get 4, and I take the b out, so it's just 4. Okay. Now, I'm factoring what's in parentheses. I factor a 3b out of each item. I'm factoring what's in parentheses. Kaylee, Kaya? Okay. This is going to be, there's only one of the objects on our special ones that has 3 terms. Which one is it? Perfect square trinomial. So we're looking at right here, because one of them has a subtraction sign, one of them has an addition sign, and that changes what's over here. No, there's no difference or additions. You don't. That's why I didn't label them. They're both just called perfect square trinomials. Based off the sign right here. Okay. All right. So what will be this perfect square? Now, if we don't know how to do this, if we don't know how to do a perfect square trinomial quickly, we can use the Xbox method on this. Right? We can use it. We can use the Xbox method. We could sit there and go like this and say the top is 4b to the 6th, the bottom is 4b cubed. We could say what multiplies to 4b to the 6th? B cubed times 4b cubed, or 2b cubed times 2b cubed. Which one of these two would add to 4b cubed? The second one. 1 plus 4 or 2 plus 2. Well, the 2 plus 2. Right? Then we've got our b to the 6th, our 4, 2b cubed, 2b cubed. Taking out our greatest common factors, what could I take out of both of these? B cubed. What could I take out of both of these? 2. What could I take out of both of these? What can I take out of both of these? So I've got b cubed plus 2 and a b cubed plus 2. What do you notice about these things? They're the same.
So it's squared.
Right.
Like the formula.
Exactly. The formula is just a shortcut. Are you sure, Gabriela? Was that you? Oh, wasn't you? I'm sorry. The shortcut is just a formula. I thought somebody said Mr. Bates over there.
Oh, I did.
Kelsey.
Can you solve it the other way?
Which way?
The long way.
I just did on the other page.
That's how you would solve it? Is
Yeah.
That way?
Yeah.
Oh, there's no other way?
No.
Oh, okay.
Yeah. Yeah. Oh. Yeah. So the Xbox method will find it, but if you can tell that it's a perfect square trinomial, then you can skip all that and jump to just getting this solution based on the way it looks. This is something squared, this is something squared. So it'll just be the square root of both with whatever sign in between. Yes, Elias?
So it'd be 3b parentheses b plus 2 squared.
Yeah. Yeah, it's right there, Elias. I don't want to take like 1,000 hours on this, but I can make up 100 of these on the spot, and you guys can see what's going on. You know. I don't know. Okay, guys, when you're seeing these perfect square trinomials, right? Remember, it's just, but they can get a little bit more complicated, and I'll show you in just a second. Right? Let me just give myself a little more room. This ends up being, since that's a square and that's a square, that's x, that's 2. And that's double 2. That square root of that, and that's double 3. Square root of that, and that's double 7. Square root of that, and that's double negative 9. Square root of that, and that's double negative 11, right? These are all the perfect square trinomials, and they can get more complicated. So, but the process is still the same. So as long as I'm dealing with squares in front. So if I wanted to say 16x squared, that's still a square. And then what's another square? Just pick any of them. 9. Okay. 9 right here. What's the square of that? Square root. 4x, right? 4x and 3. That's going to be 12. Double it, 24. Do you want it positive or negative? Negative. So if this is a negative 24x in front, then I know this is going to be 4x minus 3 squared. Okay? As long as you can recognize the pattern. Square root of that, multiply them, double it, should be that. That's the pattern. Know the pattern. Okay? Square root of that, double them should be that. So if we come back to this problem, square root of that is b cubed. Square root of that is 2. 2b cubed, multiply, double it, is that? Yes. B cubed and 2. That comes with practice. There is no, Mr. Bates, can you show me how to do it as quick as you? No, that's just called having done it so many times in life. So we're moving on past Mia. We're to Holly. Holly, what can I take out of every item here? 2. We'll have 25v to the 6th plus 30v cubed plus 9. Holly, just to double check, square root that. 5v cubed, right? 5v cubed, square root that. 3. 5 times 3 times 2, is that 30? It is indeed. So this is that same one. So it's square root, and what's that sign? Positive. So 2 square root, and we get, you said? 5v cubed. Activate Windows. Richard's still happy about seeing that activate Windows like a year and a half later after having me as a student. He still loves seeing it. 5v cubed, and what's the square root of 9? 3. And what's that sign there? There we go. You know, last time you stepped away from your pretzels, and I had them, they were a little stale. I'd like that to not happen next time, okay? If I decide to steal your pretzels, they better be fresh. Okay.
Those have been in my bag for like 3 days, so.
Well, 3 days won't kill. Pretzels are already like the most, if you don't get soft, like fresh baked ones, a box of pretzels has to be the most unfresh tasting snack you could possibly eat. By nature, pretzels taste stale.
Was it because it was cold? Like refrigerated?
No, they tasted old. All right. Kaya's just like, well, that's just, we just coat them with a thin layer of methamphetamines. That's probably what you were tasting. All right. Hey, we're to Gabriela. Okay, number 9. What do we have here? Right, so that won't work, right? She said x cubed minus 8 squared. Is 64 8 squared? 100% yes. But there is no difference of a cube and a square formula. They either have to both be cubes or both be squares. Well, cubed is not a square. So is 64 something cubed? Don't listen to Kai. It is 4 cubed. Okay? 4 times 4 times 4 is 64. Yeah, I think number 2 on your homework is no solution.
Because like they actually made it like two different ones. Like how you said.
Oh, yeah, I hear what you're saying. And no, but like we'll see. If we get time, we'll hit the homework a little bit. We'll see if we got time. All right. So, Gabriella, what is my A? No, just X. The exponent doesn't follow. Here, I hate to say the exponent doesn't follow. Shh, guys. Okay? Here, you could say the exponent follows, right? But not the outside exponent. So, like, n cubed is my A. The square doesn't go with it. 2 is my B. The square doesn't go with it. So here, x is my A. The cube doesn't go with it. 4 is my B. The cube doesn't go with it. All right? So then using the formula of a difference of 2 cubes, what would I get? Oh, you don't got your note down. And this is where somewhere earlier in the year our Italians wowed you with their mathematical magic. No, just x minus 4. Remember, the cube doesn't follow. Ooh. Difference of 2 cubes. X. A minus B, x minus 4 times x squared plus 4x. It would be x4, but 4x is the way we'd write it. Plus 16. There you go. B squared. Good job. Bethany. Hi, what do we got? Good job looking at the problem before to give you a hint. Totally should have. Difference of 2 cubes. So this will be what? X cubed minus 5 cubed. So my A is and my B is. So let's go ahead and use the formula and we get
X cubed. No. Minus 5 times x squared plus 5x plus.
there you go.
You see how slow that was? The process in my brain.
Are you kidding me? That was like one of the fastest problems we've done so far.
Okay,
I made you feel better? I mean, no, that was terrible. Oh my gosh, what do you even do? You wake up in the morning. What kind of affirmations do you give yourself? Because whatever it is, it's not enough.
They said my horoscope said that my head will spin in a good way today.
Your head will spin in a good way today. What does that mean? Okay, Kelsey, you have our first very complicated one. I'm going to talk about this for a second. Oh, we did, didn't we? So you've got the whole answer? There are 2 different ways to do this. I would prefer, if there are 2 different ways to do it, I prefer the way that makes it work out the best, which would be using this as a difference of 2 squares to begin with. So Kelsey, could you please split this up in the difference of 2 squares? So it'd be, go ahead. Good. So then that will be but these are both what? Well, one's one thing, one's another thing. Yeah. This one's difference of 2 cubes, this one's sum of 2 cubes. So technically speaking, that's x cubed plus 2 cubed times x cubed minus 2 cubed, which means this is Let's leave Dimitri alone, ladies. I have a feeling there might be something in your hood. Okay. So, Kelsey, x cubed plus 2 cubed turns into? No? Difference, sum of 2 cubes right here. What's my A? What's my B? All right, so use the sum of 2 cubes. Oh, plus. This is the sum. Minus 2x. Ah. Plus 4. And the other one, and then x cubed minus 2 cubed turns into x minus 2 times x squared plus 2x plus 4. So there's the final solution to 11. It really breaks down, Destiny. You have to do both. If you can keep going, you got to keep going. It matters what order matters when you're with your final answer. If you used either direction, the order, I'll take it as full credit on a quiz or a test.
That's confusing. I don't know how to know if there's more to go.
You have to be able to recognize it by sight whether or not there you can go further.
What makes that going further? Because it's an 8 instead of
Yeah. That's exactly it.
factor both by the
Yeah. You are 100% correct. Raymond.
So you find the difference of two squares first,
Yeah.
and then you. I don't know what came after that.
Yeah. Then you did difference of cubes and sum of cubes. Because that ends up being a cube and that ends up being a cubed. So really quick, guys. Really quick. Let's talk about this for 2 seconds. Okay. Let's say we had x to the 6th. This is a hypothetical. Don't write it down. If I had x to the 6th minus 49, that's difference of, and you did difference of squares. So you said that's x cubed plus 7 times x cubed minus 7. Are we okay with that? Yes. Right? 7's not a cube. You're just done. Because of the fact that one ended up being 8, we were able to keep going. Does that make sense? Yeah. No? Where did I lose you? Because I can't turn 7 into something cubed.
So like even if it was plus 6, you couldn't do it because it's not.
Right. If it was 6, I still couldn't do it. Now, be careful. Let's say this. Let's do this. I mean, let me come up with another example really fast. Okay? So if I had x to the 4th minus 4. Difference of 2 squares. X squared plus, actually, sorry. There we go. X to the 4th minus 16. Everybody okay? Difference of 2 squares. Everybody down with that? No, you're not okay with that? Oh, I thought you said okay. No. Okay, I was mad. Okay. But this is difference of 2 squares. So the right-hand one could keep going. So this would be x squared plus 4 because nothing I can do is sum of 2 squares. This would be x plus 2 and then x minus 2 because I could keep going.
You can just do one side?
Yeah. You can do whichever ones you can do.
Destiny, it's because there's no sum of 2 squares. So you can't break it down farther.
That one doesn't break down further. I mean, in a higher level class, that one does break down further. That's x plus 2i times x minus 2i. Imaginaries. Then I could do sum of 2 squares. But, yeah. Okie dokie. Number 12, we are to Elias. You're right, Elias. We don't have time. We don't have time, guys. This one breaks down. I really don't have time. You have Pisha Moons. I'm not worried about your ability to read. Okay? So, I know you were, and I'm sorry. I just don't have the time. I really don't. Okay? This breaks down to sum of difference of 2 squares. X cubed minus 1 times x cubed plus 1. But you always have to remember one is a square, one is a cube, one is a to the 4th power, one is everything because 1 times 1 times 1 forever will always be 1. So this breaks down the same way as this one. This is going to be difference of two cubes, x minus 1 times x squared plus x plus 1. And this one's sum of two cubes, x plus 1, x squared minus x plus 1. And there, that would be completely factored out. I've got one short lesson to teach you guys in 13 minutes, so strap in.
What is the height requirement for the ride? What's the height requirement?
Okay.
What's the height requirement?
Huh?
What's the height requirement?
The height requirement is 6'8". Yeah. So, the answer is yes.
Well, it looks like you can't ride the ride either.
I know. We're going anyways, kids. Okay?
That's literally
I have the most risk here.
It's okay because there's a weight requirement. There's also a weight requirement. It's you either be 6'8" or be 100 pounds, and then you're safe. Anybody else, death is probably occurring. Okay? I know. That's why I picked my numbers carefully. No, she's 92, 95, 95. Okay. All right. Factoring by grouping, and I'm going to have to change one of my examples. If you have an even amount of terms, and for the most part in your homework, I believe you're only dealing with 4 terms every time, you can factor by grouping, if you can try anyways. You pick 2 of them, factor something out, pick the other 2, factor something out. You have to, in order for factoring by grouping to work, end up with the same factor in both things afterwards. You're going to see that right now. Quick, give me that face. So, okay. Alrighty. So our first example, we have x cubed minus x squared plus x minus 1. So moving onward to Pisha Moon. Pisha Moon, we're going to split this up into 2 spots. Elias, fine. Elias will stay with you. Elias, I'm going to split this in half. Out of the first 2 terms only, Elias, what can I factor out of the first 2 terms? No. X squared. Yes, not the 2. We can factor out x squared from the first 2 terms. Elias, if I factor x squared out of x cubed, what do I have left? Just x. If I factor x squared out of x squared, what do I have left? I'm dividing, so I have 1. Good. Minus 1. Okay, plus. Elias, what's the common between x and 1? 1, because there's nothing in common. I can only factor out 1, but I can write that. I'm going to write that. I'm factoring out 1, just like when you guys did the box. If I factor 1 out, just x. If I factor 1 out of 1, I get 1. Do I have the same thing in both? So I look at these are 2 items only. This is now, I want you to think of this as a binomial. Here is term number 1. Here is term number 2. There is term 1. There is term 2. Elias, what can I factor out of both of those? X minus 1 is the same in both. So if I factor x minus 1 out of both, what's left in the first one? X squared. What's left in the second one? Plus 1. And I'm done. That is now factored. So I split it in half. Out of the first 2, what could I factor out of both? They can both give up 2 x's. So it's an x squared that I can take out. If I take x squared out of the first one, all I have left is x, because I've taken 2 out of the 3. If I take x squared out of x squared, there's just 1 left out. Okay? Taking them all out.
So you... Wait, did I write that down? Oh, I did not write that down. So you just took out the 2x factors, the other 2x out, so it equal 1, and then x was left from the x cubed.
Mm-hmm.
Where the plus 1?
There's nothing I could factor out of both those, but I can always put a 1 in front of anything. So I did. Destiny?
I don't understand how you got from the 2 ones in the box, like the 2 boxes.
This is one thing and this is one thing. Just like looking over here, this is one thing and this is one thing. What could I take out of both those objects? An x squared. So I did. You okay with that? I know Don't. It's a process, okay? You okay with that? So now I'm saying count this as one thing. This is one thing. What could I take out of each of these that's the same? Well, they both have an x minus 1. So I take it out. If I take an x minus 1 out of this whole thing, what's left? X squared. If I take an x minus 1 out of this whole thing, what's left? A plus 1.
So they cancel out. Why do you have the x minus 1 on that side?
Because I factored it out. Just like I took an x squared out of these two things, I factored it out. It's the same process. Yeah.
So you just factor a lot.
Yeah. Hey. So you're saying that, all right, so now I've got x to the 4th minus, right, plus x cubed.
How'd you know that's how you do it back?
I don't know. I'm just guessing. Plus x plus 1. Okay? Pishamun, what can I factor out of the first two things? X cubed. What can I factor out of the other two things? 1. What can I factor out of each thing? When I factor x plus 1 out of this, what's left? When I factor x plus 1 out of this, what's left? Am I done? No. Why not? That's the sum of two cubes. Good job. Sum of two cubes. So this factors into x plus 1 times x squared minus x plus 1. Holly.
And technically, wouldn't the last one be a sum? Oh, there's no sum that might.
The last one I messed up on, so we're going to have to change it. I must have made a typo on the last problem. You haven't done anything yet, Kaylee. It's not like it's going to be hard.
I know this is dumb, but I don't know how you got to the last row.
So on this, a is x, b is 1. Right? And then I'm taking sum of two cubes. So a is x, b is 1, so x plus 1, x squared minus x plus 1. Well, that's this one. This turned into that. Let's just say that. Okay. I'm going to have to change the last problem because it doesn't work out as far as I can tell. So I need to do a quick change. I'm going to just change it the way I changed it third period. Please change it to that. It's going to be very similar to everything else we've done. Alicia's going to take it away. Braden, sorry we didn't get to you. We'll start with you tomorrow. Alicia, what can I factor out of the first two? X squared. What can I factor out of the other two? 1. It's not always going to be 1 out of the second two. That's why I was upset that I messed up on the last one. I'm sure I meant to make it look a little different. What can I factor out of both of those? And I'm not going to make you do the rest. Because she's Alicia.
No, I mean not. Oh, I thought you were
'Cause
like,
she-
in general. Not
I already did, Elias. I said it while I said the sentence.
Oh, I thought there was more. We were on the same page. I was like, how come you weren't gonna finish it?
Whew.
Okay, I have a question. Can you go back to the last page? Really quick. I was right. Why'd you hit me?
Because she was right. Every time she's right, she gets to hit you.
Okay, you can go back.
How many times has she hit you in your life? Okie dokie. I assumed that this was going to take much less time, so I thought you guys were going to have a bunch of time in class, so I printed out your homework sheets. You could just start with Holly and go backwards, and I'll meet you in the middle. Yeah.